Okay, so welcome everybody. Thank you all for joining this webinar. This will be about identifying components and how to test them with simple means like what I have here. My name is Clemens Valens and I work for Elektor, and I will be co-presenting this webinar with David Ashton, retired electronics engineer who lives now in Australia and who just got out of bed to present this. David has a lot of experience in recycling electronic parts over the years. He has developed tools and techniques for identifying and testing components he's scrounged from old broken cards and other equipment and whatever, without requiring expensive tools. Now this webinar is sponsored by Mauser. Let me put on a slide for that. This one. There we go. So this webinar is sponsored by Mauser Electronics, which stocks the world's widest selection of semiconductors and electronic components. Have a look at their offering. Here is the link as a convenient QR code, and the link will also be added to the description of the recording of this webinar too. And yes, as usual, this webinar will be recorded and you can view it later on our YouTube channel. As has become a habit also for our webinars, there is a giveaway. And the giveaway, I didn't have a picture of the giveaway, but it is a component box from SunFounder. And you can have a chance of winning it if you type the word components into this, in the form on this link here, this webinar giveaway link. Okay. Yes, you have to say that you have to type the code word components. I will put it in the chat also. Do that here. Yes, this is where you have to enter the word, the code word. So now we can go back to our webinar, the real subject of our webinar, which is David Ashton. David, so you are today's or tonight's for you, or this morning's presenter. How are things in Australia tonight? Can you keep your eyes open?
Yeah, you might see me putting some matchsticks there to hold them open in a bit, but yeah, I'm okay at the moment, yeah. Okay. I did get a couple of hours sleep, so I should be able to go for a bit. So yeah, all good.
Okay, and tomorrow morning maybe you don't have to get up early?
No, tomorrow morning I'm going to have a lie-in, yes.
Yeah.
No, it should be good, yeah.
Okay, so before we start, I will tell people that at the end of this webinar, we will have a Q&A session. So you can do this by typing questions in the chat box in the bottom right corner. And once again, it is being recorded and will be available on the Elektor channel later for replay. Okay, David, over to you. Take it away.
Right. Okay. Good afternoon, everyone. Bonjour for those in France. Guten Tag for those in Germany, and goedemiddag, sorry, for those in Holland. I can probably do a couple of other languages, but I don't want to take up too much time with that. As Clemens said, I'm a retired engineer. I've been in electronics and telecommunications all my life. I started off 50 something years ago in Zimbabwe, and I got interested in electronics. And Zimbabwe, well, it was Rhodesia in those days. It wasn't the center of the electronics universe, so I had to learn to scrounge electronic components from wherever I could, old radios and other electronic equipment which had been chucked out. And my dad fortunately worked for an accounting machine company, and they had a lot of boards from their accounting machines, which were getting chucked out, and these just had transistors in them, and resistors and capacitors and so on. No integrated circuits in those days. So yeah, I got my start with that. I was looking just now for a transistor tester I built that, probably 55 years ago now, but I've still got it around somewhere, but I couldn't find it. But it was a very simple thing with a battery and a meter and a potentiometer, a 500K potentiometer. And it gave a pretty accurate reading of HFE, the gain of the transistor. And I sorted out all these transistors that I got off the boards. They were a very strange type, and I'd probably been messing around with them for a year before I really identified them. I was using them because I identified the base and collector and emitter, but I didn't know what type they were. They had a strange marking on. And then just by chance in a practical electronics magazine, which I got at the time, I saw a transistor which looked like it. It had a very strange case. If you look at my component identification article, which was I think from last year, the end of last year. Yeah, then I did identify those, and there's a picture of them there with the part number and stuff. It was a 2N2926. Anyway, I went from there. I've always been a great scrounger, and I still am. I suppose it comes from my misspent youth. I don't know. So yeah, any sort of old boards like this one here, for example. Let me try and hold it up a bit. You probably can't see very well, but that's actually got. Is it? I think it's. This board's got an 8031 microprocessor on it, and various other through-hole chips. Most of them are socketed. And that'd actually be quite a nice board to strip because you can get the components off fairly easily. This one here, I got off a few old tape drives. There we are. Again, that one's a Z80 based one, but it's got some nice bits in it, mostly again through-hole chips. It's got this nice display here. Where are we? There we are. It's got this nice display here, which if I unsoldered that, I'm sure it would still be working and so on. So yeah, old boards like this can give you a lot of parts. Obviously, the other reason you'd want to identify components is if you're trying to fix something. So you need to be able to identify what's on the board that might need fixing. You've also got to be able to test and so on, but one of the skills, you get burnt out components and so on, and one of the skills is being able to identify what kind of component you've got. This is a much more modern board. This is actually off an old network router, and this is mainly through-hole parts. You do have things like voltage regulators. There's a voltage regulator there, which could be useful. There's crystals. There's a lot of the chips are like ball grid arrays or whatever, and they wouldn't be any use to anyone. But there are some SOIC chips, small outline integrated circuit, which are, I always try and get those off because they're still useful for hobbyists. You get various functions, voltage regulators, 7/4 logic, that sort of thing. You've also got on this board, there's a nice relay here. Yeah, there's a nice relay there. It's a 5-volt relay with, I think, 10 amp contacts. Yeah, so off boards like this, you can get a lot of good parts that you can use in your projects. So that's one source of components for your projects. All right, identifying the components. What you're looking for is a marking on the component that tells you what it is. Obviously, something like this, through-hole components, they're easy. They have good markings on them. They're fairly easy to identify. You stick the part number in Google, and it'll normally come up with something that you can use. SMD components, surface mount devices, are a lot more difficult because the writing is very small. You need something to be able to read it. I've got this, which is a magnifying glass with LEDs in it, which is very useful for looking at small components. I've also got a USB microscope, which I don't have with me at the moment, but that's a very nice device for looking at very small SMD components. I will be showing you later some of the pictures I got with my microscope before I couldn't find it. I had my carpets replaced in the house some time ago, and had to pack everything up, and I haven't unpacked everything, and there's a lot of things hiding in boxes still. So yeah, there we go. Okay, one thing I did was a case study. I've got this small board here, which is actually a plug-in board from a network router. And yeah, I see Clemens has brought up the slides for it. There's a better picture of the board for you. There's various things on here, transformers, these little yellow things, which at first glance appear to be capacitors. There are some strange little integrated circuits here, some transistors at the top, a power transformer, what looks like it. Okay, so yeah, slide 2, Clemens. Yeah, okay, there we go. That's slide 2. These things here are SOT 223 outline transistors. SOT 223 is the package name. The name on these, let me get my notes here. The name on these is FZT705, and on the back side there are two more called FZT605. They're actually Darlington transistors. They've got fairly good ratings, 120 volts, 4 amps. So pretty useful little transistors there. Slide 3, Clemens. Great. Okay. In the red box there, the little integrated circuits there are a very strange package. They're like SOIC 8 package, but they have this tab here. I don't know if you can see my mouse here, but if you look on the left-hand side of the package, two of the pins are combined into a tab, which is actually a heatsink tab. And what these turned out to be, okay, the markings you get on these, the first ones I got were like the ones on the left, LH1540, which sounds like a good part number, okay, and then V431. Now there's another little IC called TL431, which is a voltage reference, and they're very common on the type of boards that I get. So this is pretty confusing having 431 on there. Okay. However, I got some more later, which you can see this one. The writing's not so clear. The one on the right, LH1540 again, but it says V628 instead of V431. So obviously the 431 is like a date code or something like that. LH1540, if you stick that into Google, you'll very easily get it's a kind of opto-isolator. Because it's got the tab on it, it's quite a beefy one. You can use it for driving things fairly directly, fairly heavy loads directly. It's quite a nice little chip, but I could not find it with this package. And it took me about probably half an hour to an hour's work to actually find a data sheet with this package on it. So, sometimes identifying things on Google is not that easy. You can get the right thing, but not the right package. And it's fairly important that you do find the data sheet with the right package on, because if you get the wrong package, it just might be something else. So beware of that sort of thing. Just before we go, the V on these integrated circuits, they're made by Vishay, which is they make quite a lot of nice ICs. And if you see a V on its own on a package like this, it's a pretty dead giveaway that it's a Vishay egg. So if you see that, then you can get onto the Vishay site and just search on there, which saves you a lot of trouble just searching generally on Google. Okay, Clemens, slide 5, please. The little chip on the right-hand side there with the red border around it, that's an Atmel AT93C46. It's a little EEPROM. It's only a 1K EEPROM, but you see plenty of these on old boards of the type I scrounge. They're little 1K EEPROMs. This one's an SPI. You see those more on professional equipment. However, hobbyists tend to use the I2C version, which is a 23C46, but you don't get many of those. But a lot of microcontrollers these days can cope with SPI chips. So yeah, you'd be okay there. Next slide, Clemens. Slide 6, please. Okay, this is the backside of that same board. This little ick here is an LT1373. Fortunately, it's got the complete part number 1373. I have come across LTX, that's Linear Technology, who have now been taken over by Analog Devices. This one is it's a little voltage regulator, boosting voltage regulator, which is quite a useful little chip. Linear Technology are good, and Analog Devices have kept all their old data sheets on the Analog Devices site, so they're fairly easy to identify and look up data on, get a data sheet. Next slide, Clemens. This chip here foxed me for a little bit. It says on it, it's got a Texas Instruments logo in the top left, and then a bit of a group 49C8T6T, which doesn't really make much sense. It doesn't sound like a part number. And then underneath that, there's 2064AI. Now, the 2064 combined with the Texas Instruments logo, that's also a pretty good giveaway. If you see a logo on a chip and you can identify it, then go to that manufacturer's website. In this case, you go to the Texas Instruments website, you stick into the search box 2064, and up pops a data sheet for the, I think it's what's it called, the TLE 2064A. A lot of you will be familiar with the TL064. It's a quad operational amplifier, JFET input. And that's what this is. It's an enhanced version of that with very good specs. Yeah. Next slide, Clemens. Yeah, there's a very close up of the IC itself. Yeah. By the way, these close-ups of the ICs were done with my USB microscope, which is, as you can see, it's a really handy device to get a good view of the writing on very small ICs. Next slide, Clemens. This chip here is a bit of a funny one. It's a very thick chip. It's probably 4 or 5 millimeters in height, unlike the normal chips, which are maybe 1 or 2. If you'll put up the next slide, Clemens, it's got a bit of a better view of that chip. Again, this is not a very good photo, but you can see the thickness of the chip. This was also done with my USB microscope. The chip has got D256. Now you can see on there it's got a V on it as well. So again, this is a Vishay chip, and I was able to identify that on the Vishay site. The D256, it's an ILD ILD256, ILD256T to give it the full name, which is a dual opto-isolator with AC inputs. It's got diodes both ways across the input pins, so very useful for detecting AC current from something, and it's just got a straight transistor output, but quite a useful little chip. Next slide, Clemens, slide 11. These are transformers. Now, this card, this little plug-in board that I'm showing you here, was intended to be a voice interface for a router. If you wanted to drive something with voice traffic, we used to use it for our radio network. That we used to get the output to and from the radio network through one of these boards. So these transformers are almost certainly audio transformers. Now they've got quite good numbering on them. There's a number in Midcom, which is quite a well-known transformer manufacturer, and PF450, which may or may not be a part number. But I have tried and tried and tried to get a part number for these. I have found some for sale, but they don't have any data on them. And yeah, so they're very, very difficult to get data on that. You will come across things like this. It looks like it's got a good part number on, but you won't find much on it at all. But in this case, sometimes you're trying to identify something, but you have a good idea what it is. In this case, I know these are audio transformers, and in fact, I've taken some off another board, and they are audio transformers. I've got an inductance meter and tested the inductance both ways, and it's a 1-to-1. It's actually a 1-to-1 center tap winding transformer. So if you do anything with audio, you might find these useful. Next slide, Clemens. This one again, that's a little power transformer, a ferrite core power transformer. That number CTX02-13274. Again, very difficult to find data. I didn't look very hard. I did find some for sale, and among the ones I've had for sale, they had it had power transformers 11 to 16 volts to 70 volts at 60 milliamps. Now, that in itself, even though it doesn't give me a full data sheet, it gives me a rough idea of what this is. It's a step-up transformer. So if you get your inductance meter and do a few tests on the thing, you'll probably find which windings are the highest inductance ones, and those will be the high voltage windings. And you may be able to use this in a little inverter or something. Next slide, Clemens. Right, these funny looking capacitor things. I thought when I first came across these that they were capacitors, but they've got a marking on. They've got a marking on called X017. Now, from experience, I thought, oh, these are polyfuses. They're pretty thick for capacitors. Polyfuses tend to be a bit thicker. Polyfuses, I did an article in Elektor recently on polyfuses. They're fascinating little devices. They're like a resettable fuse. You pass current through them, and because of their construction, they heat up and go high resistance. So if you use them as protection in a circuit, then they will go high resistance and limit any excess current. And when the excess current is removed, they will go back to their normal resistance. Pretty useful little devices. I didn't find any data on these directly, but fossicking around, I came across a data sheet by Littlefuse, who make these sort of things. And they have one almost identical size. They give the sizes on the data sheet and the ratings. And they have one called REXF017. And then they even have their marking on these as X17, X17, and mine are marked X017. So I'm pretty sure that these are an equivalent. They will hold a current of 170 milliamps, and they'll trip at a current of 340 milliamps, which is double that, which is a usual specification for one of these things. Again, pretty useful little devices, give you automatic protection on a circuit. You don't have to fussy around, replacing blown fuses. And also, these are fairly low rated. They're 170 milliamps they'll pass. So you won't find a fuse that'll blow at that, anything like that. Yeah. Next slide, Clemens. Okay, these are some transistors I got from another board. Now, for a minute, forget about the one in the middle that says BCP69 on it. I initially got quite a few, probably 20 or 30 of these off some other boards. And all they have is RLX or RLW or R48 or whatever, and CE on them. And okay, I've got the on semiconductor on semi logo there, which is that's fairly much a dead giveaway as well. You can go into the on-site and stick that in, and you should get something. But alas, you don't. I looked on the on semi site, and I tried to look up SMD part codes and so on, and I couldn't find anything. There are people have got long lists of part codes up on the internet, which do give you what the part number is. But in this case, I wrote off to onsemi support, and they were very, very good. They came back to me very quickly, very helpful, and said, no, this is their code. CE is their code for the BCP69. Excuse me. However, in the interim, I disassembled another board of the same type, and they'd obviously used different transistors from a different manufacturer. And that one in the top at the middle has got BCP69 on it. Now, why onsemi couldn't actually write BCP69 on it, I don't know. They've got quite enough room, as you can see. But this is what you sometimes come across when you're trying to identify components. So, right, Clemens, that's it, I think. Okay, obviously that's not all the components you'll get. You'll get SMD resistors, capacitors, diodes, that sort of thing as well. Diodes normally have some sort of part number on them, obviously SMD codes as well. So SMD code lists are quite a handy thing to have. But most of the other components, apart from transistors and stuff, you can actually test if you've got a meter. That's the easiest way to identify what they are. Capacitors, SMD capacitors are almost invariably not marked unless they're tantalums. So if you get a tester, a capacitance meter, you can sort your components as to what capacitance they've got, and you will be able to use them. Diodes as well, stick them on your meter. It'll give you a forward voltage reading. Anything with 0.6 of a volt is a silicon diode. Anything with about 0.2 or 0.3 is a Schottky diode. So you can sort them out into that, and you will be able to use them a bit. You do get confused sometimes. There are sometimes things like surge protectors which look like diodes, but they'll actually, like, they're almost like a Zener diode. They'll conduct at a certain higher voltage. So when you're identifying components, testing them is also a good part of the job. Right, so let's move on to component testing. What do you need to test components? The basic thing is a multimeter, and most of you will have or know multimeters like this. That's a basic, pretty basic multimeter which you can get for sort of $10 at parts shops. It does resistance, AC voltage, DC voltage, AC current, DC current. They do have a little socket, this little yellow socket here is a transistor test socket. It's got EBC marked on it in various combinations. So you can test transistors with this meter as well, which is a pretty handy facility. And if you're really short of funds, then these little $10 meters are actually pretty good. They're good value for money, and they do a fair bit. But I've always recommended, if you're starting out, then spend a little bit more money for about $50 or maybe $100 maximum. You can get a very much better meter. I couldn't actually find one exactly like I wanted. This is an automotive meter. Let me go a bit away there. Yeah. This is an automotive meter, but it's got a lot of ranges. It's got a thermocouple socket here, so you can plug a thermocouple in and test temperature. This one, being an automotive meter, has a lot of RPM scales, but it does have frequency scales as well, going up to 32 kilohertz. You can get meters these days, really fancy meters, which will do, apart from the usual voltage, current, and resistance tests and transistor tests, they'll test capacitance. You can test capacitors sometimes over quite a wide range. You can look at frequency. You can sometimes look at temperature, like that one has, if you've got the right probe. Sometimes even inductance. I have seen multimeters with inductance on them. And if you're starting out, a meter like that is a very good thing to have, because it saves you buying a lot of other test equipment. For testing capacitors, this is an LCR meter, the first LCR meter I've got, which is actually not working at the moment. But it'll test resistance, capacitance, and inductance over a fairly wide range. That one cost me about $50. It's a single frequency device, which means it only tests at one frequency. I've since bought a much better one, which again is packed away, which has you can select the frequency up to about a couple of hundred kilohertz, I think. And it also, in addition to testing the capacitor and the inductance, it can give you an ESR reading on the capacitor. That's equivalent series resistance, which is important, especially for electrolytic capacitors. For inductors, it can give you the Q of the component as well, which is sometimes important to know, and very much wider range than a simple thing like this. Sorry, just let me get my notes here again. Okay, now that's all fine and dandy. Semiconductors. You can test transistors with a straight meter. As I said, those little meters, most meters these days, in fact, have transistor test sockets, and they're fairly good. They'll give you an HFE reading. But they're not that good on things like power transistors, which normally have a fairly low gain and need a fair bit of current to give you a proper reading. I did build a transistor tester, which was the thing I was trying to find when I was starting out 50-something years ago. And all it was a meter and a potentiometer, and it gave quite accurate HFE readings. But what I've built since then is this power semiconductor tester, which was in the last Summer Circuits edition. It's a fairly simple circuit. All it is you put 12 volts on the lead here. It's got a light bulb in it. Which puts a 300 milliamp load on the component. It's got various switches for selecting what you're doing with it, whether it's a PNP or P-channel MOSFET or NPN or N-channel MOSFET, or a triac or an SCR. I've got some sockets here which can plug in fairly large transistors or the normal size TO220 and stuff like that. It's got a switch and some touch pads which can apply voltage to the base or gate. It was very simple to construct. All it is really is a couple of switches, a couple of resistors, and a light bulb. And it'll identify whether a triac or an SCR or a MOSFET or a transistor is working, and it'll also test diodes. If you're interested in making something like that, have a look at the last Summer Circuits issue. It's well worth having. I've used this a lot since I built it, to identify components I've got off boards like that. No, that's fine. That's fine and dandy as far as it goes, but sometimes you want something a bit better than that. This thing, which I think Elektor sell now, it's made by Peak. It's called the Peak Atlas DCA Pro. Now, this claims to be able to identify a very wide range of semiconductors. Let me try and get it so you can read it there. Okay, this one is testing a little device. You can see a little transistor-like device on those clips there. This was a transistor-like goodie I got, which was numbered OV8F or Naught V8F. I'm still not sure what it is. This was a little device I got off some boards some time ago, and it was pretty strange. There were a whole lot on the boards. There were like 4 on each board, and I thought, okay, it's a FET or a transistor, bipolar junction transistor. But it resisted all my efforts to test it and all my efforts to identify what it was. So eventually I bought one of these and stuck that on, and straight away it came up and said, it's a triac. Now, triacs like that are fairly small, but they can be very useful. So I'm actually very happy I was able to identify these with this meter. I forget how much these are. I think they're about, I think they're nearly $100. I'm not sure. I think Elektor do offer these, but they're very worthwhile. They can test an awfully wide range of components: voltage regulators, transistors, triacs, FETs, JFETs, Zener diodes, ordinary diodes. Yeah, there are 2 versions of it. There's a DCA 55 and a DCA 75, and the 55 is a little bit more limited. It's about half the price. But if you can afford it, stump up for the DCA 75. I'd really highly recommend these. They're really good. Obviously, that's fine, but when it comes to ICs, what do you do? ICs are a bit more difficult to test. Analog ICs like op-amps and that sort of thing are fairly easy to test, but you will need to make a little jig for them. I'm in the process of making something at the moment. I will maybe put an article in the magazine when I've done so. But op-amps, you can wire them up as an astable multivibrator and just get them flashing LEDs. And that's a good way to test them, but you need to make a little test jig to do that. Logic X are a bit more difficult. I discovered this device, which is made by a company called XJeku. It's really intended. It's a USB plug-in device. It plugs into your computer, and you need to download some software for it. But it's basically an IC, an EEPROM programmer. It'll program just about any sort of EEPROM or microcontroller that you want. But it also has a facility to test logic ICs. And it's got a pretty good library of 7.4 series and CMOS logic ICs. You plug it in, you select the logic IC test, plug your IC in, and select what type it is, and it'll give it a test. It's not absolutely foolproof. I have fooled it a couple of times. I think the 7.4 LS21, which was I forget what it was. It was like a gate or something, a quad gate. But yeah, it had 2 pins on it, which are labeled not connected on the data sheet. On the actual tester, it actually tries to read those pins, and it'll tell you the IC is faulty every time. And I thought, no, this is a bit strange. But the nice thing is it lets you edit the test sequences. And if you get in and those NC pins, you mark as NC not used or NU not used, and it will test that IC fairly well. So it's a very good thing to have. You can get these on the internet. I don't think Elektor sell them. It's called an XJeku Pro, and there's various versions of them. The newer versions don't test very old EEPROMs like the 2708, but not many people use those anymore. So it's a very good thing to have if you have to test logic ICs. I am working on an idea at the moment for testing just about any IC you want, but you have to make up test jigs yourself. It's basically going to be a base that you plug boards into with sockets for testing op amps, maybe 555s, various other types of audio amplifiers and that sort of thing. It'll have on it like a pulse source, maybe a little oscilloscope, an audio source maybe, and you can, when you plug in your test board, it'll automatically route the right signals to the EC. It's very much in the idea stage at the moment. The other thing you can do is make your own test equipment. I have another one here somewhere, I hope. Oh no, sorry, I haven't got it here. I made myself. There's an article in the last summer circuits as well. I get a lot of dip switches off boards, and they can be problematic. They can have odd switches that don't work, especially if they've been sitting for a long time and got a bit of dust in them. So I made myself a dip switch tester, which is basically 10 LEDs, 10 resistors, and a 12-volt source. And as you close the switches, the LED will light. And the secondary function of this is that if you put another LED in place of the switch, it'll light both of those LEDs and show you that your LED is working as well. So it's a dual purpose thing, an LED tester and a dip switch tester. And you can make this sort of thing yourself fairly easily. Just have a think about what you're trying to test, what you're trying to do, and how you're going to test it, how you're going to show that the thing's working or not. So yeah, to be a bit inventive about it. Right, that's about it. Clemens, anything you can think of that I've forgotten?
Okay, I'm back now. Yeah, I wanted to, well, first of all, you mentioned the semiconductor power semiconductor tester. I built one after reading your article. And as you can see, I put it in a transparent box, and it's really nothing. It's just 2 resistors and a bunch of switches. I have 2 light bulbs because I didn't have a 12-volt light bulb. I had 2 6 volts in series. And I needed it to test some SCRs. And it was really enormous, very practical. So I really recommend other people building it too. It's an easy build, and it's a very useful instrument or device. What I would like to add to your identifying components is sometimes you have components, you look at it, but you don't know what it is. If you look around it, so what it is connected, so the circuitry that's around it, and draw the schematic a little bit, you can sort of narrow down the purpose of the IC. of the part, and that might help you find it. If you can, for instance, I had to do this today. You find a component that is driving something, and just by looking at which pin is driving what, and then that gives you an idea of the part you are looking at, and then you can look for data sheets of parts, similar parts, and then if you are lucky, you find a part that have the pin out that looks like what you have on your board, and so that's another way to identify components. It's more time-consuming, of course, but it's in the case where you really don't know what you have, it might help out.
Yeah, well, that's exactly the thing I used on this board. I knew this board was an audio interface designed for interfacing with 600 ohm audio circuits. So these little transformers, although I couldn't find any data on them, they're 600 ohm transformers. I'm pretty certain of that. So, again, yes, look at the context of the board. What's the board used for? If it's an audio board, you're likely to find audio amplifier chips and that sort of thing. If it's a digital board of some sort, you're more likely to find digital ICs. So yes, context is pretty important as well, especially if you're trying to fix something.
Yeah, we can move on to the Q&A while we're at it. I see someone asks about component tester of an oscilloscope like found in the HAMEC ones. I have one of these oscilloscopes and I used it a lot, really. It's a really practical tool. It puts out AC voltage. You put a diode on the probes and you get the curve, etc. You can identify capacitors, broken capacitors, broken semiconductors. So yes, these HAMEC testers are really good, actually. I don't know if they're available in the new digital scopes.
I'm not sure. Yeah, I have hiding in my storeroom. Someone gave me a non-working Tektronix oscilloscope. I don't remember the part number, but it was a very old Tektronix oscilloscope. It only goes up to 2 megahertz, but it's one of those ones that has plug-in modules, and one of the plug-in modules is a curve tester for transistors, which you can still find on eBay if you look. So if I can get this oscilloscope working, I might splash out on one of those.
Those are the big oscilloscopes. I think our colleague Jan Buiting has a lot of those.
Yes, he would love this Tektronix oscilloscope because it's from his era. Yeah. Yeah.
Let me see if there is other questions. This is U curves.
Someone's mentioning Lissa U figures there. They can also be useful for testing. If you get to know your Lissa U figures, then you'll know what's a capacitor, what's an inductor. If you put it on with a resistor and put your probes across it and so on.
Yeah. Okay. If you have any questions, please put them in the chat box. In the meantime, I will giveaway slide. And remember that we have a giveaway, the SunFounder component box, of which I do not have a picture. If you write the code word components, it's a very difficult code word, in the form that is at this URL, you have the QR code and the URL, and it's also in the chat, then maybe you will win this component box. And
there's a question here, Clemens. Can you use a multimeter to identify NPN, PNP, and what pins are C, B, and E? Yes, you can. Where's my multimeter? Okay. My little $10 multimeter here. The little yellow socket there where my finger is it's got 8 pins and it's labeled E, B, C, E, C, B. Oh, and I can't read the other two. The light's not too good in here. But yes, it has emitter base and collector in various combinations around that little 8-pin socket. So you can plug your transistor in. Okay. The two sides. There's two sides. The 4 pins on the one side. Let me get that right up. The 4 pins on the one side, this side, are NPN, and the 4 pins on this side are PNP. So you can plug your transistor in just about any combination of the legs, And what you do is you put your meter onto the, there's the HFE setting. Okay, put your meter onto the HFE setting, and at the moment it's reading 0. Okay, when you plug your transistor in, if you get it right, the HFE reading will go up to a reasonable value, which, you know, on a normal kind of transistor, I would expect anything between about 50 and about 300 or 400. So, you know, yes, you can identify. It takes a bit of messing around. Once you get it right, you'll get a decent HFE gain reading. If you put it in wrong, you won't get anything. So it takes a bit of messing around getting it right. But when you get the good reading, then you can identify the B, C, and E leads, and you'll have a bit of information about your transistor as well.
Yeah, I never use those.
Yeah, sorry, I see the
I,
guy says it was not really a question. I use this and it works very much. So it does, yeah.
yes,
But
like I was
usually you
saying,
won't be able
I
to
never
find
use
which
this
one is
socket.
E
I
and
always use probes directly on the part.
yeah, you can, but it's fiddly. You know, if you're trying to identify, you know, you can use the probes directly, and a transistor is basically 2 diodes, so you can identify the diodes and normally find out which lead is your base. And you won't know, as someone pointed out, you won't know which one is emitter and which one is collector. That's when you plug it into your transistor tester, because if you plug a transistor in the wrong way around with E, B, and C, if you go C, B, and E instead, it'll give you a reading. Maybe your HFE will be very low, like 10 or something, if you're lucky. If you plug it in the right way, you'll get 200 or 300 or something. So yes, then you can identify which one's which.
Okay, I don't see other questions, actually.
The peak DCA tester identifies this automatically. That's true. I tried my thyristor in my Triac, sorry, in a lot of different combinations, and every time it tells me, you know, the leads are colored on this one. There you are. Yeah, you got red, green, and blue leads, and it'll tell you which. It tells you. Okay, Triac, red G, green MT2, blue MT1. And if you connect it differently, it'll tell you which one's which. It's a really good little test of this. Thoroughly recommended.
There's a question about the Joyit T7. Didn't you try it? I think you tried, no?
No, I've seen that on Elektor, and I'd quite like to get one. Yes, it does do the same, and it's an awful lot cheaper. It's not as versatile. It doesn't test the same ranges of components, but it's pretty damn good. It's good value for money. I hesitate to say I'd recommend it because I don't know it very well. Yeah, but it's it certainly looks as though it's a good value for money little tester.
An unrelated question I saw passing by. The old webinars, yes, all the webinars we do are recorded and posted on our YouTube channel. So if you're looking for a particular webinar, you can go to the Elektor YouTube channel and search for it. It should be there. This one also is being recorded and will be online probably tomorrow.
Is it possible to find a defect capacitor on a board without desoldering it? Yes and no. I have found defective capacitors like that because electrolytics for example, might go short circuit. But electrolytics can also go dry, which means they'll be basically open circuit. So it'd be very difficult to find that.
Actually, this circuit that I have in my hands here, we published it a few months ago, is a tester for bad capacitors. It's an analog tester. This is a nice analog meter. And here you can measure the, you can set the voltage, etc. And it will tell you if the capacitor is bad or not. So it was published in the 7 July issue. So 2207, that's the June-July issue, I think. Or is it July-August? I never know.
So yeah, I seem to remember seeing that, and I thought it was interesting, but yeah, I just haven't had time to go back to it.
Yeah, so it's the ESR tester, and it works really well. You can find it in some summer edition, not the summer circuit edition, but the edition before the number.
Yeah. inject low voltage, then it gets hot. Yeah, that reminds me of the first breadboard. I built a breadboard into a little case when I was about 17 or so. And yeah, I used tantalum capacitors for my smoothing. It was just using, well, it wasn't the smoothing, it was on the output of the regulators, the 7805 and whatever. And they were very old tantalums and they went short circuit, which is a problem with old tantalums. And yes, I identified that by the smell. It made a hell of a smell. So that's also, your sense of smell is a good test instrument as well.
Yeah, your fingers too.
Could the Elektor Lab site host a shared page with questions and answers about found components? I can't answer that, but that would be pretty useful. Yeah, you will find a lot of forums which you can ask questions like that. But generally, unless it's a fairly simple question, you don't get a decent answer. Yeah.
Yeah, the ESR tester. I saw a question. This tester works with in-circuit capacitors. That's the good thing about it.
Yeah. As long as the capacitance is sort of fairly isolated from any other things, if you look at say smoothing capacitors, you often find there's you'll get a whole lot on a power bus. You'll get a whole lot of capacitors there. So if you connect across one capacitor, you're effectively connecting across maybe up to 4 or 5. So yeah, you've got to be careful, but you can do it. Yeah.
Yeah, you of course always have to know what you're doing.
Yeah. ESR only tests serial resistance, not parallel. Look, basically that's true. ESR is equivalent series resistance, and most meters will indicate that. If you've got parallel resistance, then you'll see it as leakage. If you put a multimeter on a capacitor, you'll get a kick if it's a needle one, or the reading will go up, and eventually should get to more or less infinity. If it doesn't, if you're getting a steady reading, then yeah, your capacitance has got a parallel resistance, which means it's not a very good capacitor. Yeah. Bob Parker from Australia. Go Australia! Made a very cheap but very good ESR meter. Yeah, there are a lot of designs around. I was thinking of building myself one until I got my I think it's made by Multicomp. It cost me a couple of $100. My LCR meter, and that does ESR for me. So yeah, I didn't really want to build one myself after that. From which Elektor, Clemens, you better answer that. From which Elektor issue comes this capacitance tester? You did say, I think, yeah, have you still got it?
Yeah, that's, like I said, I put this label on as a 2207. That's our internal code. The project code is 210017. So that would be, I think, the July-August edition of this year, which is not the summer circuit edition. This was the edition that appeared just before. And it's called, I didn't put, it's called the ESR meter, analog ESR meter, I think it was called. 210017. If you look for that number, then you should be able to find it.
Yeah. I like things with analog meters. In fact, I've got tons of analog meters lying around, and I'll always use one in preference to a digital display if I can. I'm just getting old, I suppose, but yeah. I remember I started off in telecoms, and in the days when you had analog phones with capacitors in them and that sort of thing, and there were guys there was a tester that they could put on the line, and it put a voltage on the line, and because telephones have capacitors in them, you got a kick on the meter, and then it went back to 0 again. And there were guys who could look at this meter and tell you what kind of phone you had on it, because they had different values of capacitance in them. And they could tell you, yeah, you've got 2 phones on that circuit, 3 phones on that circuit. Yeah. You wouldn't do that with a digital tester.
No.
Can you show the link to the giveaway again, Clemens?
Well, I just pasted it in the chat.
Oh, okay, there you go, yeah. Oh, someone just mentioned digital tweezers. I think I've got one here. Yeah, digital tweezers. Okay, this is not a digital tweezer. This is just a tweezer probe. Okay, it's just a probe that you can test SMD components, diodes, and capacitors, and so on. Basically two tips there connected to two two banana plugs, which you can plug into your multimeter. So plug that into your multimeter, stick your probes onto the component, squeeze until you get the connectors at the end of the capacitor or the diode. And it's very much easier than messing around with probes, which always slip off and so on. Really good value. I don't know if Elektor sells these, but you can find them quite easily in most electronics shops. I think they're made by SparkFun, but they're like about $10, and they're well worth it for testing SMD bits and pieces.
Good. To come back, oh no, just sorry, mixing things up. I have these tweezers also. I'm not sure if they are sold by SparkFun. I got them somewhere in a DIY shop. There was a question for the reference of the EEPROM programmer you showed.
Okay, I should be able to.
In the meantime, the code word is components, plural.
Right, I should be able to find this. Hang on a sec. I've got my component testing article up here, and there was a sidebar about that tester. Okay, it's called a TL866. TL866. You get various types of them. I think I did put a note about them here. Yeah, TL866. Thanks, Clemens. Okay, there are various versions. Okay, the current version, which is what this one is, that's called the TL8662. It's got like an II, Roman numeral 2 after the part number. That's really the only one you'll find these days. They're all very similar, but the only difference really is the software. As I said, the more modern ones can't test very old EEPROMs like 2708s and stuff, but or program them. But yeah, I bought this primarily as a logic IC tester, and it's pretty good at that. Yeah.
Okay. Well, I think we're almost.
Time flies when you're enjoying yourself, huh?
Yeah. Yes, it's almost 5 o'clock. We have filled our hour. Well, you have filled the hour more or less. As there are no questions anymore, let me then close down this webinar. So I keep repeating this. This webinar will be available probably starting tomorrow on the Elektor TV channel, the recorded version that is. The next Elektor webinar, as I saw it, it will be the microcontroller as pixel artist, which will be about graphics, doing graphics with a microcontroller. But I didn't see a date, so maybe someone who is in the audience from Elektor and who knows the date can type it in the chat box. If not, then please keep an eye on the webinar announcement page or on the newsletter. It will surely be announced in the newsletter also, to which you should subscribe if you didn't do so already.